Hello everyone and welcome back to the DAO Adventure. Today we are building a voting system. This is project 4 out of 5 from the DAO Adventure training. The training is divided into 5 guided projects where I help you implement those projects in Motoko. The goal of the training is to get you ready for the graduation where you will build and deploy your own DAO and earn your Motoko Bootcamp Diploma. Today, we are building a voting system for our DAO. DAO are decentralized autonomous organization, and they need a way to take decisions in a coordinated manner. This is why we usually have a voting system. Voting system can be built with token, with role, or even with staking. There are many ways to build a voting system. Today, we will implement a very simple, not realistic voting system, but this is only for training and educational purposes. As usual, we will use the DAO Adventure training repository, and I will open this repository in Gitpod. My workspace is ready, so I'll jump into days, day 4, and projects. I'll put main.motoko on the right and project.md on the left. As always, you can open the Markdown file and start to read the instructions for the project 4. Project 4, the collective voice. Walking through the academy, you hear a mix of different sounds, like music. Following the sound, you come to a big area. Inside, students are grouped together, each singing a different note or using a different instrument, yet harmoniously contributing to an enchanting melody. The guiding artificial intelligence floats by and whispers to you, just as in music, a DAO should translate individual voices into harmonious decisions. You're about to learn that in a DAO, making choices isn't about the loudest voice, but about ensuring every voice contributes to the collective song. It's time to orchestrate your DAO's voting system, letting every member strike their note. Your mission is to create and implement a voting system. Specifically, in this level, we will create a voting mechanism for changing the DAO's manifesto or adding goals as defined in level 1. So as you can see, this level relies on variables and functions implemented in previous levels, so it's advisable to complete those first if you haven't already. If you look at the main.motoko file, you will quickly realize that we have imported the code from project 1, project 2, project 3, and of course project 4, because this is project 4. This is because you will make use of those data structures and variables in the project of today. So this is the first time that we need the code of previous project. Those are the requirements of your voting system. So requirement number 1, only members of the DAO are able to vote and create proposals. Requirement number 2, the voting power of each member should be equal to the number of tokens they hold. So as you can see here, we will need project 2 because we need to look at our members. Here we will need project 3 because we need to look at the balance, so we need to take a look at the ledger. Creating a proposal should require to burn 1 token. Once again, we will need to interact with the ledger. A member can only vote once. Every time a member votes, the score of the proposal is updated. Depending on whether or not the member voted for or against the proposal, the score should be increased or decreased. For instance, if a member with 10 tokens votes for a proposal, the score should be increased by 10. If the same member votes against the proposal, the score should be decreased by 10. A proposal is automatically approved if the score reaches 100 or more. A proposal is automatically rejected if the score reaches minus 100 or less. Otherwise, the proposal is still open to voting. Any approved proposal should be automatically executed by the DAO. As you can see, this is a fairly simple voting system. I can take a look at types.motoko, and here you can see that essentially you have in the proposal, you have the ID of the proposal, the content of the proposal, which is either change manifesto or had a goal. Proposal status can be open, accepted, or rejected. And the most important thing is the vote score here, which is the score that we calculate and compute every time some new member vote. And so this score is updated based on the voting power, which depends on the token of the voter. To help you get started, we have defined different types in types.mo. So as you can see, you have the types from project 2 because we need them for the project 2 part of the code. And also you have project 4. So you have proposal ID, which is a NAT64. This is the first time that we are seeing a NAT64. Proposal content is a variant type. So you have either change manifesto or add goal. Proposal status is also a variant. It's either open, accepted, or rejected. Vote is an object that contains the member that voted, so the principle of the voter, the voting power at the moment of the vote, and yes or no, which indicates if the member voted against or for the proposal. So if it's true, then the member voted for the proposal. If it's false, the member voted against the proposal. And then we have the type proposal, which contains the ID, the content of the proposal, the creator of the proposal, the time of creation, the time of execution. The time of execution is optional because maybe the proposal has not been executed yet. A list of the votes, a vote score, and of course the status of the proposal. As you can see, we are now on project 4, and so here we have a less indication than previous levels. For example, here in the task number 1, you will need to create a data structure, but you have to choose by yourself which data structure you will use to store the proposals. And also you have less indication for the other functions. As always, we have the interface that you need to respect. Now is the time for you to start coding, and good luck. I'll be there for the correction in a few minutes. Make sure to pause the video and work on this project, and I see you in a few. Alright, so let's move to the correction. I hope that you've successfully implemented this project. If not, don't worry, I'll correct and explain everything. The task number 1 was to create a data structure to store the proposal, and I'll use the proposal IDs, and so I will store the proposals in a hash map. And I'll use the proposal ID as a key and the proposal as values stored inside the hash map. Our keys are going to be of type NAT64, so I'll use NAT64.equal, which is a function from the NAT64 module, and I'll use NAT64.toNAT32 to convert and hash my NAT64. And for that, of course, I will need to import NAT64. We also need to define a variable, stable variable proposal next proposal ID, which will store the proposal ID of the next proposal. So it's essentially a counter for our proposal ID, so that every time we create a new proposal, we increment this variable by 1. Okay, so now we can move to the task number 2, which is to create proposal. And so for that, we need to make sure of a few things. The first check that we need to run is to check that the caller is a member. We also need to check that the caller has enough token, at least 1 token. And then we need to create the new proposal, store the new proposal, increment our next proposal ID, and burn the token. If you're not sure about all the check that I've written here, please take a look at the requirements for the create proposal and for the project in general. The first thing that I want to do is check if option.isNull members.get caller. So here I'm using a function from the option library. The option library is useful for working with optional value. Members.get will be an optional value. If it's null, then it indicates that we don't have any member associated with this principle. And so essentially option.isNull is a method that returns a Boolean indicating if the provided parameter is null or not. So if it's the case, then we can return an error. You need to be a member to create a proposal. After that, I can check my balance. So balance of the caller is going to be option.get ledger.get color, and if there is no balance, then it's gonna be 0. If the balance is below 1, we can return an error and indicate you need at least one token to create a proposal. Just a quick recap, I'm using the option module from the base library, and I'm using option.get, which is able to unwrap an optional value. And I'm using this new method called option.isNull, which essentially takes an optional value and returns true if the argument is null, otherwise returns false. So that's what we need here and what we need here. Once we have done all our check, we can create the proposal. So let new proposal. And we need to fill all the fields. So we need to take a look at the types.motoko file. Here we have the ID, which will be next proposal ID in our case. The content, which will be the content provided in the parameter of the function. So here, content is equal to content, and this can actually be abbreviated in Motoko by this syntax. Then the creator will be the color. The time of creation will be time.now. So this is a method from the time library that we can use. We need to import time. Oops. And it will record the current time in nanosecond. Then executed will be initialized to null because we haven't executed this proposal yet. Votes will be initialized to an empty array, and the score is initialized to 0. Finally, the status will be open initially. So we have created the new proposal. Now we can store it. Proposals.put, next proposal ID will be our key, and the value will be new proposal. Finally, we can burn some token, and we can increment the proposal ID. To burn, I will implement an helper function, so I've already done it here. Essentially, I'm not using this burn method. I could, in theory, use this burn method, but this method is a public function from the body of my actor, so it's a shared function, and if I call this function, I will call it through the IC messaging model, IC message system. So essentially, it's going to create just like an inter-canister call. It's going to go through consensus and then call my canister. So I'm calling myself, but I will add the delay of the consensus, and I will have asynchronous answer, which I need to await. Of course, I can make a synchronous version of this method. I've removed the check, so essentially this method can trap in case the amount is above the balance of the owner. And also I've added an underscore. This is a personal convention that essentially every time I have a public method and I make a synchronous private version of this method, I like to have an underscore and the same name just to make the distinction between the two. This is a personal convention and it's not something that is part of the Motoko language. So I can use this burn method, burn color and one token. Here we know that it's not trapping because we know that the balance is at least 1, so we don't have any issue. Then we can increment the proposal ID. Next proposal ID is equal proposal ID plus 1, so this is essentially a syntax abbreviation for this. If you're not familiar, this is exactly the same as doing this one. Proposal ID plus 1. And I can finally return OK. We also need to specify the proposal ID that we've just created, so don't make the mistake of sending the proposal ID, because this one is actually the next one, and what we need to do is remove 1. And we know that this will never be negative because we actually are starting from 0 and then we are always incrementing by 1. So this is at least the minimum value would be 0 here. Now we can move to get proposal. Get proposal is fairly easy to implement. We just need to do proposals.get and then the proposal ID. We don't even need to switch and make sure that the proposal ID exist because we are returning an optional value here, so this is totally correct. Next, we want to implement get all proposal. This is fairly similar to what we have already seen. So we need to return an array and we need to iterate over all the values inside the proposal's data structure. Finally, the vote proposal is the method that will take more time. We have more check to implement and we have quite a few things to take into account. So I will take a look at project.markdown, open it on the right. Just make sure I take into account all the requirements that we have. So the first requirement is going to be to check that the caller is a member. Then we need to check that the proposal exists, because we have a proposal ID that is passed here, but maybe it doesn't exist for this proposal ID. Then we need to check that the caller has not already voted, because we can only vote once, as you can see here, per proposal. And then we need to compute new proposal. So essentially we need to compute the score, the new score, potentially the new status, and modify the proposal's data structure. And finally, this is an optional step, but if the proposal is accepted, we need to execute the proposal, because it's the latest requirement. Any proposal should be automatically executed by the DAO. Any approved proposal should be automatically executed. All right, so let's jump in. We can take the same check that we have here for this method, so we can take that. Then I will use a switch case because I want to check that the proposal exists, and if it exists, I want to access the proposal. So that's why I'm using a switch case, as you will see. If we don't have a proposal, we can return an error. No proposal found. The key is not the caller, the key is the proposal ID. But if we have a proposal, I can access it by unwrapping it with this syntax. And now I can play with it, so I can check that the caller has not already voted. For that, I will create an helper method as voted. This takes a proposal of type proposal and a principal of type principal, and it returns a boolean, as you can guess. So essentially returns a boolean indicating if the submitted principal has voted on the proposal. For that, we will need to take a look at the proposal. And so in the proposal, we have the list of votes. So that's what we want to iterate over. So for votes in proposal.votes.values, and the vote object is here. And so if one of the voters, so member corresponds to essentially the person that voted, and the vote was recorded. If member is equal to our principal, then it means that we have already voted, so we can return true. And after the loop, if we haven't found any, well, it's vote.member. If we haven't found anyone, then we can return false. Here I can use my helper function if as voted, proposal, and then caller, then return an error. You can only vote once per proposal. Okay, so we are now in the compute phase. So we have made sure that we are a member, we have made sure that the proposal exists and that we have not already voted on it. So now we can finally vote on this proposal. And for that, I will create a helper function, which is essentially a function that will create a new proposal based on the proposal that we already have and based on the voter, so on who is voting, and based on the vote, so essentially, is it a yes or a no? and I will return the new proposal. So the first thing I want to do is get the voting power. So my voting power is essentially my balance of tokens. So once again, we can use option.get ledger.get voter and then 0 in case we don't have any balance. Let multiplier. So the multiplier is essentially a value. So a value that I will use, you will see. So essentially if my vote is true, so if I want to vote for the proposal, I will use a multiplier of 1. If I want to vote against the proposal, I will use a multiplier of -1. That way I can compute my vote. So vote score is gonna be voting power multiplied by the multiplier. And you will see that this works if I vote for or if I vote against. And now I can compute the new proposal, which is going to be, so we need to take a look at the votes, at the types of the proposal. The ID will be unchanged, so this is going to be proposal.id. The content will be the same, again, proposal.content. Creator will be the same, proposal.creator. Created will be the same. So we have a lot of fields that are exactly the same. This is because in Motoko we cannot just modify fields, we have to recreate the object, and I want to return that object. Executed will be the same for the moment as well. The votes, the votes, I need the new votes. So the new votes, I want to convert buffer.toArray, so buffer.fromArray. So I want to get the votes here from the previous proposal, so from the proposal, and then I convert that to a buffer, and then I do new votes dot add, and I will add the votes, so the current votes, which is gonna be member is voter, voting power is voting power, so I can simplify that, and then yes or no is gonna be yes or no, so I can simplify that. I just want to, okay, so record that vote, add it to the buffer, and then finally buffer.toArray, convert that back to an array. So I need to specify what is inside the buffer, and those are votes. I'm doing all of this just to convert the array to a buffer, being able to add element and then converting back to an array, because in the proposal it's a type array here. Then the score will be the previous score, so proposal.score plus the score. So vote score, maybe we can rename that to color vote score, which makes more sense, just to make it different from this one. Essentially, this is the score that is provided by my voting power, so the voting power of the voter and the multiplier. And because of the multiplier, you will notice that this syntax, so the plus, works in the case I'm voting for, but also works in the case I'm voting against. And the status, we need to compute the new status, so the new status can also be a variable here. If the new, so we need, well, actually first we might need to compute the new score, that will be easier, so I can actually do that before and then just use it here. Because for the status, the new status, I actually need the score. If the new score is above 100 or equal to 100, then the new status will be accepted. So this one. Else, if the new score is below or equal to -100, then we will return rejected, else we will return open. So this is slightly complex syntax, but just keep in mind that we are just assigning the value to the variable here, and then we can use the variable in this line. status is equal to new status, and then we can return the new proposal. So we have all this code, which is slightly complex or slightly long to write, but then when we use that in our method, we can make it very simple by just doing let new proposal is equal new proposal, and we pass the parameters. So proposal, the old proposal, the voter, which is the color, and yes or no. And then we can do proposals.put, proposal.id, and new proposal. So we are replacing the data structure with the new proposal. Finally, if new proposal.status, so we need to check that if it's accepted, then we need to execute that proposal. So we need to do execute here. And we need to essentially create this helper function. Finally, we can return OK. To create this helper function, we simply need to create a function execute, which takes a proposal and execute this proposal. And we can make it synchronous. We need to switch on the proposal.content, which is actually where the role and the goal of the proposal is stored. And proposal.contents can be either to change the manifesto with the new manifesto as a parameter, or it can be to add a goal with the new goal as a parameter. So in this case, we'll just do manifesto is equal to new manifesto. We are taking the variable from here, so this is this one. And in a similar manner, we can do goals.add new goal. Finally, in both cases, we need to change the executed field of the proposal. So we need to do let new proposal. And again, we need to copy all the fields. So sorry for that. There might be some improvements to the Motoko language coming up soon where we won't need to do that every time, but right now we need to do that. So everything needs to be exactly the same. The votes, the score, the status. Except one field, which is executed, needs to be time.now. So we finally have executed our proposal. It needs to be optional, so we need to add this question mark. And proposals.put, so we need to actually store it so that our modifications are stored. And after that, we can return. And we are correct. So we are done with project 4. So we can try it out and deploy it on the playground. Dfx deploy playgrounds, projects 4. This is the Candid UI for our project. So we can see that we have all our methods. We have the create proposal method, the get proposal method, and the vote proposal method. So I will try to create a proposal. Let's say add a goal, finish Motoko Bootcamp. And this should result in an error because I'm not a member of the DAO. You need to be a member, so I will create my member profile. And it should still be an error because I don't have any token right now. You need at least one token, so I will mint some token. And for that, I need to mint, let's say 101 tokens so that I can create a proposal and then I can vote on it and it's gonna be executed automatically because I have 101, then it burns, so I have 100, and then 100 token is enough to pass a proposal. And I need my principal, so right now I'm using the anonymous identity. And so I need to check what is the principal for the anonymous identity. And I never remember the value. So what I can do is take a look using the FX. This is this one. Copy this one, mint some token, and I'll be able to create a proposal. Okay. everything is good. So this is my proposal ID that is 0. I can take a look. If I look at get proposal, I have my proposal that is open. Right now, no one has voted for it. So I'll be the first one to vote for it. I'll vote true to pass it. And it returns OK, and it should already have executed my proposal. If I take a look again, yes, accepted. So it's accepted. The voting power was 100 at the moment I voted, and executed has already been filled. So if I take a look at my goals, it's inside the goals. Finish Motoko Bootcamp. All right, so that's it for project 4. Hope you've learned a lot from this project. It was not necessarily the easiest one. Good luck if you've made it so far. I see you in the next video, and in the meantime, keep building.